thanks for coming to Office Hours today. This is a program where we invite luminaries from the software world to share insights. These are one-on-one sessions with experts, and they've been a huge success. I'm Lauren DeMeuse, partner and COO at Theory Ventures, and I'm delighted to introduce our discussion today. We'll chat in the fireside format for about 40 minutes. Please feel free to ask questions within the chat box, and we'll see if we can intersperse them along the way. And to begin, Tom Tunguz is the general partner at Theory Ventures, our $230 million fund focused on companies leveraging technical discontinuities into go-to-market advantages. Prior to founding Theory, Tom spent 14 years at Redpoint as a general partner, where he made investments in Customer, Looker, MotherDuck, some other great companies. We're joined by Jordan Tigani, CEO and co-founder of MotherDuck. From the founding tech lead on Google BigQuery, chief product officer at Single Store, and now master of waterfowl puns, Jordan is the preeminent voice on data architectures, someone who starts with the critical question, how is this data actually going to drive decisions, and architecting from there? Nothing is worse than using a superpowered mega data platform and realizing you get the work done 10 times faster on a local notebook, which is my experience often. So today we have the chance to probe these experiences, and with that, I'll hand it over to Tom.
Jordan, welcome to the show. We really appreciate you being here. And as Lauren said, everybody in the audience, if you have questions for Jordan, please surface them as we go, and we will weave them into the conversation. But Jordan, we've known each other for a while. I think the thing that stands out most to me about you is you've seen this data ecosystem blossom basically from the very beginning, the big data ecosystem. Maybe you could just walk us through a little bit of that journey and how that brought you to writing the post, "Big data is dead."
Sure. So I worked at a startup before I was at Google, before BigQuery. And this was in the days of where everybody's like, big data is coming. And this startup actually they had their pixel on 10% of the internet and had a huge amount of data. And I'm like, wow, this is really a thing. And Google has the best handle. They were way ahead of everybody in terms of what you could do with large amounts of data and processing data in parallel, et cetera. And so I'm like, this company really gets it. And that was a time when I think Doug Cutting from Hadoop said, Google is living 3 years in the future and sending us messages. Anyway, so I went to Google, wanted to work on big data, and I found myself on a team that was supposed to build a data marketplace, and we ended up building BigQuery instead. But it just seemed, I would go around the world giving speeches about big data is coming, and look at these graphs and how much data is increasing. And we built this highly distributed system, thousands of nodes. It's now millions of nodes that can all run in parallel and in concert to solve this problem. And we were able to handle really large data sets and some of the largest customers in the world, Walmart, Home Depot, Equifax, HSBC. And one of the things that I was doing is at some point I switched over to lead product at BigQuery. And so I was looking at it, comparing what is our effective data warehouse size and trying to compare that with competitors and match it up with Snowflake, et cetera. And I was basically almost all of our customers were using a small amount of data, they were actually processing a small amount of data. They might have a lot of data, but a lot of it was just logs that would sit there for a lot of time. It was just it was shocking actually how small the data actually was. 90% of queries sub 100 megabytes. And this is tiny. And then I went to Single Store for a couple of years and noticed some of the same things, is that people wanted a smaller instance. We sized our instance to be equivalent to a Snowflake XS, which is their smallest instance. And people wanted a smaller one, so we made it half that size. They wanted a smaller one, so we made it half that size. And we could still actually solve people's problems. We made it smaller and it just wouldn't work because it wouldn't scale down that small. And then I found DuckDB and they could scale down, but just the recognition that kind of the way we've been building systems to make them larger and larger data sizes was not actually all that relevant to most users. There was a guy that I talked to, and I go to these conferences and I hear about the Netflix architecture and I get all excited and that sounds really cool. I want to go home and implement that. And I was like, what do I do? Build a one node Spark cluster? It's just way more for the size of data that I actually have. And then you see Snowflake and Databricks fighting in their sort of their benchmarking wars. And if you look at the data size that they were using 100 terabytes, 100 terabyte. And that is larger by an order of magnitude than Walmart uses in their largest queries. and Home Depot. And so if that's what they think is important, that's an order of magnitude larger than basically the largest customers in the world that do routinely, then like there's got to be this opportunity for focusing on the sizes of data that people actually have and what kind of things can you do differently. So that was the impetus for writing that Big Data is Dead. Is hey, we've been like told big data is coming, and for so long, and just for most people, it like hasn't actually impacted them. They still use the same amount of data that they operate on routinely that they did a decade ago. Because I think one of the things is that some of these tools make it possible to access large amounts of data, but they haven't made it inexpensive. And on BigQuery, you can do a petabyte table scan, like that'll run, but that'll cost you $10,000. You're not going to do that all the time. And people end up collapsing, summarizing, looking at the more recent data, and that tends to be a pretty small amount. There just seemed to be an opportunity to do things differently.
Yeah, and I think that's a brilliant summary. As part of the big data ecosystem becoming bigger, it's also become a bit more complicated to get started. In order, like you said, spinning up a OneNote Spark instance, and that's one of the things that I think DuckDB and MotherDuck really shine, where it's just really easy to start with the data set, whatever size that you want, in whatever format, JSON, integration, Parquet, hitting Postgres. Are you seeing that within the community? And how does that ease of use matter?
I think ease of use is the critical thing like these days. And I think the reason that people love DuckDB and like people love DuckDB in a way that like is just not common with sort of database infrastructure. And the reason they do is just because it's so delightfully easy. If you're writing in Python, you do pip install DuckDB, import DuckDB, and then DuckDB can actually query directly from your data structures in Python. So you don't have to move data from the database, or you don't have to like import things. It just works. They have the world's best CSV parser. Like in BigQuery, we put a like college grad, very smart college grad working on our CSV parser. And then we're like, okay, that's done. We'll move on to something else. DuckDB like wrote a research paper on it. They have one of their like top engineers working full-time on CSV parser, because so much data is in the CSV and so much time that people spend is like butting their heads against, oh, there's like this bad row, or how do I set this to null, or how to like, and the CSV, and so DuckDB, you just point at your CSV file and it figures it out, and it's fast. And so I think this ease of use, the simplicity of getting started is really important. Snowflake's not that hard to get started. Redshifts maybe a little bit harder. BigQuery is pretty easy, but GCP throws up a bunch of hurdles when you try to just get started. But none of the big players are really focusing on, and I think Databricks is very hard to get started. I think Spark is a bit easier, but you do have a bunch of additional machinery. But people aren't just really focusing on like, how do I get started, get something done in seconds rather than minutes.
Yeah. So that ability to, as an individual user, pip install, start manipulating CSV data, start building bigger and bigger data sets, raises the question, which is once a data set becomes really large, or I want to start sharing and using the data, sharing the data with others, how do I do that? And that's where MotherDuck comes in. Can you talk about like one of the key advantages or the key changes in architecture is hybrid execution that I think will become a really important part of the modern data stack here in the next 5 to 10 years.
So hybrid execution it's a platform on top of which you can do a bunch of things. And so one of the things that becomes possible is, as you were mentioning, as your data sizes start to get bigger, you want to go from local to cloud, persistent, sharing with coworkers. And so we want to make that as seamless as possible and as much like DuckDB as possible. Like DuckDB it's just simple, it just works. And so the way MotherDuck works is we're an extension to DuckDB, and our client is always DuckDB. So if you're using DuckDB locally and you're working with your CSV file and you're running your queries against your Python, your Pandas data frame, you basically just create a database that starts with MD : M for MotherDuck, and then that runs in the cloud. So everything you do now is running in the cloud. And if you have a local database, you can basically select star from the local database or select into the remote database from your local one. and it just works. And you can join those together. You may have a large shared data set in the cloud. You might have the private data set locally. You can join those. You can move. It's just easy. And that's really our goal, because there's also the case where people are prototyping things. And this is one of the common things for DuckDB is you sort of prototype things locally. You try things out like, hey, this is great. And you're like, okay, well, now I need to go into production. I need to find another database because like I need it to be hosted. I need it to be scalable. I need all these things. And that's where MotherDuck comes in, because you just change your database name and boom, it's running in the cloud.
We have a question from the audience, Jordan, from Dr. Jan, who is around ease of use. And the question is, it seems like he has a collection of students and he's trying to teach them to onboard to MotherDuck. And he's curious if you found large language models are helpful for onboarding users. So this might tie into a broader conversation around the use of machine AI, like generative AI, within the MotherDuck platform. How do you think about onboarding users? MotherDuck recently released a open source text-to-SQL model. How does this all fit in?
So LLMs are quite good at summarizing documentation and making it easy. So being able to ask an LLM questions. So we're actually working with a couple of providers, but Run LLM is one. And so actually in our Slack channel, you can ask Run LLM actually some pretty hard questions, and it gives you answers that probably a lot of people at MotherDuck don't know the answer to, and it can actually give pretty high quality answers. So I think that in general, to help onboarding, to help understand what are best practices, these types of things can be really good. And I think the other side of it is for people that either are just learning SQL or they may be rusty on their SQL, LLMs can be really good at helping you improve the quality of the SQL that you write. For example, we have this feature we call Fix It, and you're writing your query, you run a query, and there's some sort of syntax error, and it points out a suggestion for a fix. And very often, like and it works quite well. And what it can let you do is it can let you just like type what you think should work, instead of having to like stop as, oh, I can't remember the parameters to this. I'm going to go over to the documentation and I'm going to find the documentation and come back, and you lose your focus, you lose your flow. But this way, with Fix It, you just type what you think should work. And sometimes it works. Sometimes you get it right. Sometimes you just remember the correct order of the parameters. But when it doesn't, it'll fix it for you. And because, oh yeah, that's right. The syntax is interval 3 days. It's days plural and not day. And that just works. So I think there's a lot of opportunity there. And I think we're also going to be continuing to push on how to do that better and better, and just making it easy to write SQL.
Great. We talked a bit about ease of use. It's really easy. MotherDuck's really easy to use. You have the AI feature, which can help you fix. We've got this hybrid architecture where I can start with a small data set and then burst to the cloud when necessary. But this hybrid execution also allows software applications themselves to be rewritten with a new architecture.
I think typically we've just gotten used to when you want to show a graph or you want to show a dashboard, you click and then you wait, and then you wait a few seconds and then it updates, and then you click and then you like look and you click again. I think and one of the reasons is just because you have this expensive server running somewhere and it's 100 milliseconds away in terms of just ping time, the speed of light. You can't actually make it faster than that. And when you move it down to the browser, then you can get just really reactive user experience. You can get 60 frames per second. You can fly through your data like it's a video game. And we're providing a WASM, a Node, or a JavaScript client that lets you embed this into your applications in a really easy way. And so you can drag a slider around and have everything update at 60 frames per second, which is literally impossible if you have to hit a server in the cloud. But some of the things you're doing may be actually hitting cloud resources, and we can fetch some of those in the background. Or if let's say it's a portfolio application, you want to slice and dice. Generally, just about everybody's portfolio will fit in memory in the browser. But if you want to do something hypothetical, it's like, okay, what if I bought this, or what happens if I did this? Then that has to hit the server, but that's all seamless. Maybe you have to wait like 100 milliseconds for the first batch, and then you can slice and dice it locally. So there's just a lot of opportunities to show to users something they've never seen before in terms of reactivity and response time. And on the other side, if you're the vendor building these applications, anything that runs in the browser, you're not going to have to pay for. So it can be much less expensive than running on some expensive cloud hardware.
That latency, you and I know from Google, latency matters a lot, right? 100 milliseconds in the end user experience meaningfully changes click-through rates. It changes the way that people feel about a product because it tends to be slower. I remember like a Twitter GIF video of somebody using a fork trying to eat a sausage with 100 milliseconds of latency and then 500 milliseconds of latency and then 2 seconds of latency. It becomes increasingly comical. It's the same with your data, right? If it takes a really long time, you'll analyze it less frequently. And like you said, the gross margin advantages, I think, will be significant. For a lot of software applications, ultimately, like this latency gross margin benefit could be a pretty significant differentiator over time, particularly in very competitive markets.
And there's the one other interesting thing that is related to those types of applications is our tenancy model is also different in that DuckDB can shrink down to be tiny, and that's how it can run in the browser. It's 100 megabytes. It can also shrink up quite large or expand to quite large. Like essentially the largest EC2 instance, which is, if you think about it in terms of like snowflake sizes, like the Snowflake 3XL is roughly the same amount of hardware, and that's like $1 million a year. And we can give every single user their own DuckDB instance. Very often, like a SaaS vendor, you'll have some really large active users, and then you'll have usually there's a power law drop off, and then there's a really long tail. And each one of those users gets a DuckDB instance. The ones that are in the long tail that are mostly quiescent don't cost you anything when they're not querying. And then the ones that are very large, we can scale up to basically as big as they need to be. So it just gives you peace of mind that those customers aren't stomping on each other. You don't have to bin pack them yourselves. And you pay for what you use. You don't have to worry about sizing things. The sizing is exactly what people need when they need it.
You can handle that breadth of scale in a single product without having to transfer or re-architect. That's awesome. Can we talk a little bit about like the ETL world? Whatever, you're a big software application. There's a bunch of data. You need to get it into MotherDuck. We've seen some companies or some projects starting to use DuckDB as part of ETL pipelines. How do you think about Duck and ETL? What does the future of that world look like? Where do you want to play? What's important to users?
So I think one of the things that often people underestimate is like the work needed to get data from its sort of raw format in various other locations to something that is actually cleaned up and usable to put in your dashboards that you want to show to, that you want to make your business decisions based on. And I think the industry has gone to an ELT model where you load it into the database and you make a bunch of changes, or you use the database to do some transformations as you're loading it. And as a data warehouse, that MotherDuck in general and DuckDB by extension are going to have to be good at this. And because it's just, if you want to get data in and you want to actually do analytics, you have to do a bunch of data transformations. And so this is where working with partners is really useful. Like we work well with DBT and DBT Core, and we're working on getting in DBT Cloud. We have a Fivetran connector and a Fivetran destination. We're one of the first Fivetran destinations that's not one of the big cloud hyperscalers. And it's just because it's super important, because if people can't get their data in and can't get data in the format that makes sense to their users, then it doesn't matter how awesome your data warehouse is or your database is. It's not actually useful. And that was like one of the first things that we first started talking about MotherDuck. People were like, "Wow, this sounds really cool, but like, how do I get my data in?" And if you can't and so a big proportion of what we're doing has been just around ecosystem and making sure that we have a wide variety of connectors, and whatever tool you want to use works to be able to get your data in, do your transformations. And DuckDB is quite a good data cruncher. It's good. You can do some really large scale data transformations, and I think there are some best practices that we're learning, but just like any database has its own best practices about how to do some of these things.
Maybe we can take a fun little detour here. So one of the things that I really admire about MotherDuck is a sense of humor, like that mug, perfect timing. Brand has become a critical part of the business from day one. I remember when the first website launched, and you have this really unique voice where you play a lot of puns. Are you using ChatGPT to come up with those, even in the board decks, right? When we talk about the balance sheet of the company, it's Duckets, and it's head of product, right? Who is there? Are you the person responsible for all this humor? Is it distributed through the organization?
I think the humor is pretty distributed. Tino, one of our co-founders, one of my co-founders and head of MotherDuck, is probably our like chief punning officer. He comes up with a lot of the puns, but like our finance person came up with the ducats of the board deck. And finance people are not usually known for their humor. I think we all have a little bit of a sense of humor, and we also just don't like taking ourselves too seriously. We take the product seriously, we take customers seriously. But we think life is more fun and works better if you don't think too highly of yourself. And I think that's also, we have some really amazing people, but all of them are super humble and willing to do what is necessary, which is a nice side effect of some of this lighter type of environment. And yeah, you're right. It is. And it's just a different brand, and people are not used to seeing something as lighthearted. And sometimes people are worried they can't take us seriously. And I think that's just something that we'll have to just prove that you can take us seriously.
And you live that mentality. Whenever I think about you on stage at Data Council in an inflated duck costume giving a talk on really deep database infrastructure. And so that sort of irreverent brand, I think you're right. It's a real foil, a real contrast within the overall industry. And I think it ties into the ease of use and the lightheartedness, and just feeds on itself. So it's a brilliant thing to see, particularly for a product that's and a company that's being developed bottoms up, having that, if you think about Slack, right, like that voice within the product, you have the same thing within the business. And it's really hard to capture. Rare.
I think this is what we are as a startup team. Like, we're doing with a large proportion of our waking hours are devoted to this, and of our stuff that we think about and focus on. And if you're not having fun, and if you can't have fun, why do it? It's got to be about the journey rather than the destination. And if you can build a fun place and you can attract other fun people to work there, and then it can be a self-reinforcing kind of thing.
To just jump in on that, I was curious, there's a lot of that personality. I assume that translates into your community. Could you talk a little bit about the community development and your strategy to get all of those devs and to share in that lightheartedness, that playfulness? How do you think about that work?
Yeah, I think so. One of the things that's been nice is by having this brand and having this, like, we have a couple of think pieces. There's a bunch of people who come out of the woodwork and are, I believe what you guys are. I believe that big data is dead, or this speaks to me. And so that's been really nice, because when you start out, the product's not perfect. It's missing features. Sometimes you hit some reliability snags. But when people believe and are on board with what you're doing and how you're doing it, it's a lot easier than if they're just, it seems like a nice database and we chose this one because it said it was going to be faster. But if people believe that this is the future of analytics, then they want to be a part of that journey. So we have a lot of people in our Slack who are believers. We reach out to them and we're trying to do this sort of people focused PLG, so people-led growth. And a lot of what that means is we reach out and try to understand and try to work with some of these folks. And so a lot of them we'll just hear this. They're really excited about DuckDB. They're excited about what we're doing. And sometimes they don't even have a use case yet, but they're like, I'm just waiting and I'm waiting for this. And that's been really, really nice to see. We had somebody yesterday who said, what was it? I love everything about your product. I love the design, the philosophy. And this is the most excited about our product in 10 years. And that's pretty nice. That's pretty cool. And not everybody, and that's what we live for. And we want to happen. And because we believe that if you can make a handful of people feel that way, then you should be able to get a lot of people to do that.
That's great. Yeah, no, that's a phenomenal answer. I think you're right. If you think about if you're building a next generation analytics stack, or you're building a hybrid SaaS application, that's a multi-year journey, right? As a person who's proposing that as an architect, making a big bet on the future of that movement and having that deep sense of alignment, both with the people and the ultimate product direction, is critical. Awesome. That brings us to the end of the agenda. Jordan, I've learned a ton. It's such a privilege always to be with you. Talking about the history of big data, 90% of workloads are less than 100 megs. It's crazy. You could put it, I was trying to do a really archaic analogy in my mind, which is how many floppy disks would that be?
I used to do that. Like there was in Google Next, I was on stage, and this is where I had the querying a petabyte in BigQuery, and like showing that you can query a petabyte, and had a bunch of, this is like how many floppy disks, I think it were CDs, would be like 10 times the height of the Empire State Building or something. But then I just realized like that, yes, you can do this, but no, nobody ever actually does it, because it costs $10,000. Yeah, the thing that we didn't say is this query that I'm running costs $10,000.
Yeah. That's awesome. And then talking about like the ease of use and putting that into the community, the brand that you've infused into the business, such a unique differentiator. It's really awesome. So thank you very much for joining us and sharing all your wisdom. We're grateful.
Thank you. This was fun. Appreciate it.